also important to understand limitations of patterns. We have to be frank and realistic about how the patterns work and how they don't work, so you can be more judicious in choosing how to apply them and when to apply them. One of the limitations of patterns is that having a shared design vocabulary, which is one of the benefits we talked about, can also be deceptively simple. Sometimes people think that the software just writes itself, that the knowledge of the patterns is all that matters, that if you sleep with the Gang of Four book underneath your pillow at night, you'll somehow wake up in the morning and be more invigorated and able to express what you're doing to your teammates in a way that just has the code magically appear. Well, obviously there's more to it than that. Oftentimes there's significant, tedious, and error-prone effort required to take the concepts described in the pattern literature and convert that into source code that compiles and links and runs properly at the end of the day. One of the things you have to be aware of course, here is that if you combine patterns with other forms of systematic reuse, more code-centric forms, things like class libraries, frameworks, or service-oriented middleware, that's often a very effective way at being able to combine the strengths of patterns, which is to cover the design space, with the strengths of these other forms, which is to take the patterns and convert things into code that you can use more readily to make you more productive right away. So be aware that patterns take more than just being smart. They also take turning stuff into real artifacts that can make you more productive. Another potential limitations with patterns is if you're not careful, the de-emphasizing of implementation details can come back to bite you during later phases of the life cycle. For example, there are situations where the details really matter, and sometimes patterns, especially some of the more introductory patterns, don't give you enough information to be successful in a particular context. As an illustration of this, consider the observer pattern that we've talked about many times throughout this course. The classic description of the observer pattern in the Gang of Four book doesn't really talk much about what happens if there's multiple threads of control involved while dispatching is taking place. So if the subject is dispatching the observers, calling their update methods and so on, what happens if there's other threads of control that might be coming in to notify or subscribe or change the state of the subject in some way? Well, that's not really addressed very deeply in the pattern. And yet, if you start trying to apply observer or variants of observer like publisher, subscriber, or reactor and so on, you can quickly realize that these details make a big difference. And if you're not careful, you can write solutions that are either inefficient or simply incorrect. So it turns out that there's actually many other aspects to understanding how to implement these patterns in a broader, more diverse range of contexts. And there's a number of papers and other pattern languages actually that go into more detail that you might want to look into for learning about how to deal with some of these issues. Another potential limitation with patterns is that limited knowledge of patterns can constrain the design options that you might use when you write your programs. For example, if you only know a handful of patterns from the Gang of Four book, bridge, proxy, adapter, singleton, and so on, you may find yourself applying those patterns overly aggressively and to the exclusion of other design solutions in the software that you write. Well, that's not really a limitation with patterns per se. It's a limitation with only knowing a small subset of the potential patterns out there. And I can assure you, as you get more experience, as you get more knowledge, as your awareness of the broad range of patterns literature grows, you will find yourself in situations where you're able to pull and bring in different patterns to be more effective and give you a broader range of design options, not a smaller range of design options. But be aware, however, that there are still times when you're building some new application in some new domain, and there may not be patterns in the literature yet, or you may just not be familiar with that body of literature that will help to guide you. So there's really no substitute for thinking clearly, understanding your alternatives, talking about it with your design team and so on, in order to be able to make sure you come up with the right solution for the right problem that you're trying to address. Another challenge with patterns is that not all patterns are applicable in all programming languages. In fact, sometimes you'll have programming languages that differ in very significant ways, and either certain patterns don't make any sense at all, or if you do use them, you may need to apply different variants of those patterns. This is becoming more and more the case as people move to a new generation of programming languages that are not just conventional object-oriented languages like C++, Java, C#, and so on. as we start to see newer programming languages, functional programming languages, things like Haskell or Scala and so on, not all the Gang of Four patterns necessarily apply in those languages because many of the Gang of Four patterns assume storage of state and management of state. And some of these functional programming languages don't really emphasize that as part of their best practices. So in this particular case, what's important is not to assume you can blindly apply the Gang of Four patterns to all programming languages, but instead to take time to seek the literature that will guide you in the effective application of patterns for whatever programming language or programming paradigm you happen to work with. And I can assure you for these newer languages, there's a body of literature out there on patterns for effective functional programming and logic programming and so on.